Okay, so let's start the class. Right. So yesterday we have completed atmospheric corrosion and corrosion under installation. So the third one, which is the external corrosion, is the soil corrosion. So we will start soil corrosion today. Okay. Now, what is soil corrosion? So soil corrosion happen due to the anything which is buried. For example, underground piping or underground piping and the storage tank which is touching the soil. Okay, we will have this problem. Soil corrosion is due to the moisture and the salt content of the soil. So you know that seashore soil is highly corrosive. Now the next one is how we will measure the corrosivity of the soil. It is very difficult to measure the corrosivity of the soil directly. So generally we are measuring the resistivity of the soil. Okay, the high resistive soil, resistivity means electrical resistivity. We will pass the current. So actually voltage, we will give the voltage. How much is the return voltage? We will check. Okay, if it is less resistive, then it is highly corrosive. If it is more resistive soil means low. So resistivity, corrosivity opposite. More resistivity, less corrosivity. So how we are measuring the resistivity is ohm centimeter. Okay. So how to measure the resistivity? We have different methods. If you take it is in 570 actually, Wenner 4-pin method, soil bar, soil box to measure the resistivity of the soil. Okay. So soil corrosion depends upon the soil condition. Soil condition is mainly affected by the moisture, availability of moisture and the salt content. It is generally regarding tanks, it will be the bottom storage tank. To protect from the soil corrosivity only, we are going for a cathodic protection. So tomorrow class will be the cathodic protection. 651 cathodic protection, 652 is the lining. So cathodic protection. Or we can go for a, for example, if you go underground piping, they will not give only cathodic protection, they will give for a wrapping coating. Wrapping will also be there. Even though tank is generally very rarely it is wrapped, so we are going only for the cathodic protection. Okay, that is the best effective. Now, how I know the cathodic protection is effectively working? So inspection method for this is closed interval potential survey. So what is meant by closed interval potential survey? For example, tank means you have to go around the tank and check. Piping means where the pipe is going, they will use 2 electrodes and check whether the coating is damaged or not. If it is damaged, then it will show some voltage. Okay, these are the key points about the soil corrosion. Generally, it will affect only carbon steel and the cast iron and the ductile. Generally, stainless steels are not affected by the soil corrosion. So please take soil corrosion. The corrosion of metals from exposure to soil is referred as soil corrosion. Page number 293. We will come. I am grouping it. First, we are going to discuss external corrosion, then internal corrosion, then metallurgical change. That's why we are jumping here and there. Okay, we'll come. Everything is important. Okay, I am not following the alphabetical order. I told you the book is arranged in the alphabetical order, but this is the easy way to understand damage mechanism. So please take corrosion of metal from exposure to soil is referred as a soil corrosion. Affected material, this is the important carbon steel, cast iron, and the ductile iron. These are the affected material. Then open book question. Critical factor, the severity of soil corrosion is determined by many factors, including operating temperature, moisture and oxygen availability, soil resistivity, soil type, catalytic protection, state current, and the condition. Then C is important, closed book question. Soil resistivity related to the soil moisture content and dissolved electrolytes in the soil water. That is important. Soil resistivity depends on the moisture and the dissolved electrolytes. Soil resistivity testing is frequently used to estimate the soil corrosivity. It is easy to measure. Then soil having high moisture, high dissolved salt concentration, and high residue are usually most corrosive. If you have high moisture, high salt, then it will be more corrosive. That is open book question. Then highlight the G also. Other factors that affect soil corrosion include galvanic corrosion, dissimilar soils, stray currents, differential aeration, and MIC. Just to highlight it, they all we will explain tomorrow class. Okay, regarding the what is meant by galvanic, dissimilar soils, stray currents, everything catalytic protection will explain. Affected units, underground piping and equipment, as well as buried tanks at the bottom of above ground storage tank. So these are affected by the soil corrosion. Appearance and morphology. Soil corrosion appears an external thinning with a roughened surface and a localized deeper attack on fitting. Open book question. Now highlight the B. Poor condition of protective coating is a telltale sign of potential corrosion damage. So if the coating is damaged, that indicates there is a soil corrosion.
Sir, telltale na sir. What is meant by telltale, sir?
Telltale, what is happening inside? It is telling the tale, telling the story. Tale means story. What is happening inside?
Okay.
Poor condition protection. If a protective condition damage means it's telling that there is a corrosion is happening inside.
Okay. It's like is it like a sensor, sir?
No, telltaleங்கிறது ஒரு வேர்ட் அவ்வளவுதான். Telltale உள்ளார என்ன நடக்குதுன்னு சொல்லுது அவ்வளவுதான்.
Okay, sir. Okay, sir.
It's not a sensor.
Okay, sir. How about tombstone, sir? Tombstone shape.
Tombstoneங்கிறது this is the tombstone shape I told you. This shape is called a tombstone.
Okay, sir. Okay, sir. Okay, sir. I remember.
Okay, right. Then prevention. This is very important. The most effective protection of a combination of corrosion resistant coating and catalytic protection system. That is important. So the most effective protection is a combination. You have to go for a coating and catalytic protection. Then inspection. A close interval potential survey on catalytically protected line may be used to verify that the buried piping has a protective potential. Then highlight this one open. Refer NACE SP 169 and AP 651 for guidance of applicable inspecting and maintenance. Now, how the catalytic is a close interval potential survey. This is they are just checking it. Close interval potential you will see. There is a reference electrode. So this is the close interval. What he is doing? You can not this one. This is the close interval potential survey on the road. Just they will send the volt meter. They will hang the meter. So he is checking this. So they know how much they will make it null. But if there is any coating damage, suddenly there will be a voltage. Then that area there is a coating damage. They have to excavate it. So wherever, say, it is very simple. We will send some voltage when there is a coating. coating is a non-conductive material. So some voltage will return, we will make it 0, whatever it comes. Then we will go through the line on the above ground. If the coating is damaged, then the pipe will be exposed. So pipe is a conductive material. Then there will be a change in voltage. So a change in voltage shows that there is a coating is damaged. So we have to excavate to check the condition of the coating. That is the purpose of close interval. Why it is called close interval? We are checking very close interval. Potential means voltage. By sending the voltage, how much volt is returning, we are checking it. So if you go to the 651, we have to send at least 850 millivolt, and there should be a 100 volt millivolt return that should be there. It is not given here, it is given in 651. So please highlight this, the next one. Okay. Pipe coating holiday survey. Direct current voltage can be used to locate coating defects in coated pipes. This can be performed on a newly coated pipe before being buried. So there is one thing called a holiday survey. I think you know that. Holiday survey, we cannot do it from the above ground. For holiday survey, you have to excavate, and the actual only we can do it. That's all soil corrosion. So how many questions we marked here? 1, 2, 3, 4, 5, 6, 7, 8 questions we have marked. Now, 571, we have completed the external corrosion damage mechanism. Now we will go to the internal corrosion damage mechanism. So first one, we will start with the caustic corrosion. Okay. So first, what is caustic? What is caustic? Okay, caustic is a chemical, no problem. But a chemical can be two types. One is called alkaline, another one is called acidic. So what is meant by alkaline chemical and what is meant by acidic chemical? If pH value, pH means hydrogen percentage, pH ions. What is the pH of water? 7. Water is neutral. Water pH is 7. If the pH is less than 7, we call it as acidic. If the pH is more than 7, we call it as alkaline. Okay. Now, what is caustic? Point number 1, page number 69. Please take page number 69. Okay. Caustic, just understand it is a very important damage mechanism because there are two damage mechanisms in caustic. Caustic corrosion and caustic stress corrosion cracking. I will complete first corrosion, then we will go to the caustic is a alkaline chemical. Alkaline means pH more than 7, 8 to 40. Okay, so what is caustic is? It is nothing but sodium hydroxide or potassium hydroxide. Sodium hydroxide is NaOH, potassium hydroxide is KOH. That is the second point. It was asked in one of the closed book question, one of the AP exam. Caustic is, answer is NaOH, NaCl, like that they will give answer. Third important point is where we are using caustic. Generally, in the industry, caustic is used for two purposes. One is to neutralize the acidic product. If you want to neutralize the acid, you have to add a caustic. Another one is as a catalyst. What is meant by catalyst? To improve the reaction fast, to improve the reaction. That is called a catalyst. Now, this damage mechanism is related to the boiler and the steam generator. It is not related to the oil and the gas production. So how we are generating steam in a boiler? We will heat the water in the burner furnace. So the water will be converted into steam, and the steam will be used to rotate the turbine. So we can power generation, or we can use steam for other purpose also, some other heating purpose also. For in steam generating, caustic is added to the water to improve the steam efficiency. Caustic will improve the steam because to rotate the turbine, we need a supersaturated steam, not a normal steam. Steam should not have any moisture. We need a superset. So improve the efficiency if we are on caustic. If caustic is properly mixed with the water, there will be no corrosion. Point number one. But because of the design, if the caustic is not properly mixed with the water, if you see the boiler generally, see there will be a water header, there will be a water wall panel tubes like this, where the water will move in the tubes. The burner will be there at the top, there will be a big drum. We will connect it. When suppose caustic is freely, separately moving in the water wall tube, what will happen? Because we have a furnace temperature, the caustic will cause a corrosion in the water wall tube. That is called caustic corrosion. So for caustic corrosion, we need two conditions: a free caustic and a temperature more than 170 degrees Fahrenheit. If both are available, then it will cause a corrosion. That is called caustic corrosion. Is it clear? Now, because the water is moving in the water wall and the caustic also moving, the corrosion also will be line like this. That is called grooving. It is an exam question. How the caustic corrosion appear? Answer is grooving. This is about the caustic corrosion. So for caustic corrosion, we need a free caustic and we need a temperature more than 170 degrees Fahrenheit. So how the appearance will be? Grooving. Which material it will affect? It will affect carbon steel, low alloy steel, stainless steel if passivity is damaged. What is meant by passivity? So stainless steel, we have iron oxide layer. Sorry, what is the layer? Chromium oxide layer. If the chromium oxide layer is damaged, then stainless steel also will have a caustic corrosion. So generally it affects carbon steel and low alloy steel. In stainless steel, if the passivity means when the chromium oxide layer is damaged, it will cause corrosion. Now, very, very important, which material is resistant to caustic? Both the corrosion and stress corrosion cracking is nickel. Nickel based alloys are always resistant to caustic. Okay. So what are the nickel based alloy? I told you nickel content should be more than 30%. How you will identify the nickel based alloys? Alloy 400. Alloy, a 3-digit number, 600. So generally alloy 400, alloy 600, other nickel based alloys are highly resistant. Now, next one is how to prevent the caustic corrosion. We have to change the design. What is meant by changing the design? You should not allow a free caustic to move separately. It should be immediately water washed. It should be immediately mixed with water. Suppose you cannot change the design, then change the material. Go for the nickel based alloy. Okay, NDT, there is nothing special. We can take radiography to check the water wall grooving, or we can do UT also. But the problem is grooving means it is making a groove. Groove na trimla pallamar. But if you cut the tube and see the grooving may not be visible because it will be filled with the corrosion product. So you have to use a sharp tool to check that groove. That's all about the caustic corrosion, one of the important damage mechanism for AP exams. So please take. Which one? Maybe. So please take nickel. Localized corrosion due to concentration of caustic solution such as sodium hydroxide and potassium hydroxide and corrosive salts from this solution that usually occurs under evaporative or high heat transfer condition. That is important. So what is caustic? Sodium hydroxide and potassium hydroxide. Affected metal, primarily carbon steel, low alloy steel and 400 series SS. That is important. So it will affect carbon steel, low alloy steel and 400 series SS. Carbon steel is the metal most commonly used in a situation where caustic corrosion is concerned. 300 SS is generally resistant to caustic corrosion until passivity is damaged. That is closed book question. 300 series generally resistant to caustic until passivity is damaged. Then critical factor, caustic, sodium hydroxide, KOH must be present. That is closed book question. Then B is important. In high strength caustic, temperature above 170 degree with the temperature limit depending on the caustic concentration will cause general corrosion of carbon steel. Then affected units, low. Yes, please. Okay. Check பண்ணாதீங்க. Okay. Localized caustic corrosion, caustic gouging is most often associated with the boilers and the steam generating equipment, including heat exchanger. That line is important. Open the question. Then appearance. Caustic gouging is typically characterized by localized metal loss that may appear as a groove in a boiler tube or locally thinned areas under insulating deposit. That is important. Groove in a boiler tube. That is a closed loop question. Then highlight the B also. Deposit may fill corroded depression and mask damage below. Probing suspect area with a sharp instrument may be required. We have to use a sharp instrument. Prevention. In steam generating, caustic corrosion is best prevented through proper design. That is closed book question. So you can see next line. Damage can be minimized by reducing the amount of free caustic, by ensure adequate water flooding and water flow, by ensuring proper management to minimize the hotspot. Then highlight the C. Carbon steel have serious corrosion in high strength. Alloy 400 and some other nickel-based alloys exhibit much lower corrosion rate. That is open. We have to use a nickel-based alloys. Then NDT, nothing is there. So this is how the grooving you can see here through corrosion. If you see the cross section, it will appear like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9 question we mark. Next one, we will go to the microbiologically influenced corrosion, MIC. Again, so what is MIC? Page number
238, sir.
Right. Now, MIC is due to stagnant water. If we have a stagnant water, generally a flowing water will not cause much corrosion than a stagnant water. A stagnant water will cause corrosion because due to living organisms, fungus formation. Algae na pasam pudikudu, poosram pukuduna soram. Algae, fungus formation, we call it as a microbiologically influenced corrosion. Now, what are the key points in microbiology influenced corrosion? See, soil corrosion, which side storage tank bottom? Soil side. MIC will be on the product side because of the bottom sediment and water. If you have a stagnant water, so MIC is the problem with the storage tank bottom. Bottom means inside. And heat exchanger where the flow rate is very low. Heat exchanger also, if the water flow rate is very low, this problem will come. Okay. So MIC is due to living organisms. Generally, it will affect almost all materials. Carbon steel, low alloy steel, 300 Cs. Titanium is highly resistant. Titanium is the highly resistant. So what are the critical factors? So what is the water? Which type of water we are using? Okay, for next one, what is the salt content inside? These are some of the critical factors. Now, generally, living organisms means that what you call plants are living, or we need oxygen and light. But this one, this corrosion, no need to light, no need oxygen. Okay, only they need, this corrosion need phosphorus, carbon, nitrogen for growth. This is very important. Open the question. So all MIC damage mechanism require nitrogen, phosphorus, and carbon for the growth. Generally, nickel-based alloys and titanium are resistant. Okay, even though it will affect other materials. Now, what is the other thing is pH? There is no problem. Temperature also is not a problem. Up to 0 to 235 pH, 1 to 14, any pH it will happen. How the appearance will be? It will be under deposit attack. Under deposit means when there is a chemical deposit inside, you can see a pit. If you remove the deposit, we can see that is called under deposit attack. and another one is called cup-shaped pit within a pit. There will be a big pit. Within a pit, there will be another small pit. There is a picture is there. So you can see here how. So you can see here this one. There is a big pit here. Inside there will be a small pit. Big pit and another small pit. Pit within a pit is the characteristic of this one. Next one, how to prevent MIC. So what you have to do is MIC means if you know there is a stagnant water is there, what is going to be stagnant? You have to add a corrosion inhibitor. One option. Or you can use ultraviolet light. You can see our water filter, they are using UV technology, ultraviolet B. These are only temporary measurements. Okay. The most effective is you can go for a lining with the cathodic protection. Inside also we can go for cathodic protection. Generally storage tank bottom, soil side we are going for cathodic protection. Inside also cathodic protection is allowed. With the lining and the cathodic protection is the most effective method to prevent the MIC inside a storage tank. Okay. But the problem with the cathodic protection giving inside any leakage, current leakage will be, spark will be cause a fire because oil is here. Now finally, how to prevent it? So which NDT we will use? Here we have to take the sample water and analyze it. Only water analysis is the NDT here. Whether inside there is a MIC is happening, we have to check the water analysis. Okay, what is the soil, everything we have to check it. And if the water having smell, bad smell water means corrosion is happening inside. So these are the key points about the MIC. So please take this. Corrosion caused by living organisms such as bacteria, algae and fungi.
Sir, ஒரே நிமிஷம் sir.
English la pesunga sir, record பண்ணி.
Oh, sorry sir. Sir, for the previous damage mechanism, you mentioned me that it affects the I forgot to ask earlier, even the last time. So each mechanism where it's been like each damage mechanism where it's actually specific which part of the equipment is
it is not, there is no fixed rule. No, this is a common code.
Okay.
Okay, this code is written for all type of equipments, piping, pressure vessel, storage tank. Okay, some damage mechanism may not be purely related to storage tank. For example, caustic corrosion is generally it's a boiler related damage mechanism.
Yes sir. Yeah, that's what I'm asking for.
But they included, we have to study. That's all.
Yes sir, that's what I'm asking. Like what I'm asking is, so you, for example, caustic corrosion you mentioned as it's these caustic corrosion usually occurs at boilers and steam generators. My question is, microbiological corrosion occurs usually in which equipments?
Storage tank. It is a related storage tank, product side bottom.
Okay sir.
And the heat exchanger.
And heat exchanger. So that's what I want to make a note, because I was asked in one of the interview but I couldn't answer it.
Okay,
so storage
tank, it is a storage tank related damage mechanism. See, most of this 11 damage mechanism are storage tank related. Some of things are not storage tank related, but they included in our exam.
Okay. Another thing, sir, when you mentioned like water, it's mainly caused because of the water stagnated. You're mentioning the water stagnated, the underside of the tank or the product side?
Product side only. Product side because oil will have water mixture.
Okay.
Because of the water specific gravity is 1 and oil stored oil for specific gravity less than 1, water will go down and stay at the bottom.
Okay, sir.
That's why we have a sump in the 650 to remove the water periodically.
Okay, sir. Thank you, sir. So if you can tell me for all the damage mechanism, like what actually, the specific damage mechanism which is going to affect what kind of equipment is really great, sir. So I can make a note of
sir,
it.
when you have time, there is one thing called affected units.
Okay.
Each damage mechanism, they have given the section this. Just to go through this. If you have doubt, ask me, because generally question will not be asked in the affected unit session.
Okay.
Exam question, they will not ask which unit it is affecting. But if you want to know which, he's asking which damage mechanism affect which units, there is a separate section, but we are skipping in most of the damage mechanism. Generally, there will be no exam question. If you have time, Sriram, go through that. You can find the answers.
Okay, sir. Thank you, sir.
Corrosion caused by living such as bacteria, algae, and fungi. It is often associated with the presence of tuberous or silmy organic substances. Often the bacteria present localized corrosion, pitting, and crevice corrosion. Crevice means gap. Okay, close book question. All common materials, titanium appears to be highly resistant. That is open book question. Now, critical factors, because there are many types, organisms can survive and grow under a wide range of conditions, including lack of oxygen. Lack of means without oxygen also they can survive. Light or dark, high salinity, pH 0 to 12 and 0 to temperature. This is important. Then this is another open book question. In addition, all organisms require a source of carbon, nitrogen, and phosphorus for growth. That is open book question. We need carbon, nitrogen, and phosphorus. Affected unit, MIC is often found in water-cooled heat exchanger in the bottom water layer of storage tank and we piping with stagnant or low flow and piping in contact some soils. Product storage tanks and water-cooled heat exchanger in any unit where cooling water is not properly treated can be affected. The next page, appearance and morphology. MIC corrosion is frequently observed as a localized pitting under deposit. That is important. Localized pitting under deposit or tubercles that shield the organisms. Tubercles also form a carbon steel exposed to oxygenated water. The damage is often characterized by cup-shaped pit within a pit. That is called hollow effect in carbon steel subsurface cavities in stainless steel. That is what this is, cup-shaped pit within a pit. That's also important. Prevention. Microbes require water to thrive. Systems that contain water should be treated with the biocides such as chlorine, bromine, ozone, ultraviolet, or proprietary compounds. Often multiple biocides are needed to keep the levels of bacteria in the appropriate range. Proper application of biocides will control but not eliminate. So it will be a temporary arrangement only. So therefore, continued treatment is often necessary. Then Hutch is very important, open book question. Coating and catheterically protecting underground structure and interior of storage tank have been shown to be effective mitigation methods for MIC. Then inspection. In cooling water system, effectiveness of treatment is monitored by measuring the biocide residual, microbe counts, and visual appearance of the water. Sampling and analysis can be performed to better understand the bacteria population, while effective treatment are key in identifying the potential or MIC still can in areas of stagnant. That is open book question. Then highlight the D. Foul smelling water may indicate biological activity. If there is a bad smell, then it will indicate the biological activity. So how many questions we marked? 1, 2, 3, 4, 5, 6, 7, 8, 9. See, almost every damage mechanism we marked around 8 to 9 questions. The next one is sour water corrosion acidic. 3.58. No, I am using a different book because it is common for combined all 5 and 570. Right. Okay. Now, what is meant by sour water? See, I told you what is the water pH of water? 7. If the water is dissolved with H2S and CO2, that water is called sour water because it is highly corrosive. Because it have H2S dissolved in the H2S, so it is called as a sour water. Okay. Sour water pH will be 4.5 to 7. So the pH will be come down. So when H2S dissolve, you know H2S is sulfuric acid. This is acidic, this one. So acidic means pH less than 7. So the pH will be 4.5 to 7. Generally, it will affect only carbon steel. Nickel-based alloys are usually resistant. Then again, how to check it? This is a very simple damage mechanism. We have to check it is a general corrosion, pitting corrosion only. We have to check another water analysis. You remember I told you a little bit before, we have to check the water sample and test it. Here also we have to check the water sample and test it. What is the pH, salt content, everything. Now, how I monitor the sour water corrosion NDT is, we will use a corrosion coupons or corrosion probes. We call it as a ER probes. There is a difference between corrosion coupon and corrosion. What is meant by corrosion coupon? In a line, pipeline, for example, they will have a flange in this one. They will put a same material, a small piece. when there is a flow. So periodically they will remove it and check how much it is corroding. So based on that, inside corrosion can be monitored. That is called corrosion coupon. Coupon means actual material we are using. Corrosion probe means we are not using actual material, we are using electric resistant probes. Based on the resistivity, they can calculate the corrosivity. I told resistivity, corrosivity are related. These are called ER probes. So corrosion probes and corrosion coupons are used to monitor the sour water corrosion. Okay, so please take carbon steel due to acidic sour water containing H2S between pH 4.5 to 7. This is very important. So sour water corrosion will happen 4.5 and 7. Carbon dioxide may also present as well as other acidic species such as dissolved organic. That is open to question. Affected primarily carbon steel, stainless steel, copper alloys, and nickel base are usually resistant. That is a open to question. It will affect carbon steel only. Stainless steel, copper alloys, and nickel base alloys are usually resistant. Then critical factor, highlight the C. At a given pressure, the H2S concentration in sour water decreases as temperature increases. That is open to question. When the temperature increases, H2S concentration will decrease. Then highlight the E. About a pH 4.5, a protective thin iron sulfide layer helps limit the corrosion. Suppose if a deposit is formed, for example, iron sulfide, then the corrosion will come down because that layer will protect the piping or vessel from the corrosion. Thin layer, iron sulfide, because H2S is there. H2S when react with iron, steel have iron more than 60% iron. Then there will be iron sulfide layer. If the iron sulfide layer forms, then corrosion rate will not increase because it will protect. If the iron sulfide layer is a thick layer, then the thick layer will have a lot of porous gaps, so the corrosion rate will not reduce. That is the next line. In some instances at pH 4 point, a thicker porous sulfide film layer can form. This can promote pitting under the sulfide deposit. That also important. Thin layer will protect, thick layer will cause a pitting corrosion. Then appearance, corrosion damage sour water generally thinning. It will be a uniform corrosion. However, localized corrosion under deposit attack and especially air oxygen present. 300 series successful pitting attack and may experience crevice corrosion and chloride suspension cracking. That is open to question. Then prevention. Most of this, see, there will be a 50% closed book question. Okay, but many there will be open book. Process monitoring and control are important in minimizing excess of sour water corrosion. Process, what you have to check? H2S content, pH, chloride content, all this. And the triggers can be used at temperature below 140 where chloride corrosion cracking is not likely. That is open book question. Then this is a closed book question. Because it is a general or UT or RT is identify the locally thinned areas. You can use for UT or RT. Then again, this is a closed open book question. Strategically placing corrosion monitoring system, corrosion probes, corrosion coupon on online thickness monitoring sensor can provide a early warning. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 questions. The next internal corrosion is sulfuric acid corrosion. So what is sulfuric acid? Chemical formula of sulfuric acid. H2SO4. H2SO on the hydrogen sulfide. Sulfuric acid on the H2SO4. Okay. Page number 312. Okay. Yeah. Page number 312. Sulfuric acid corrosion. This is very important because this is only tanks related. Piping and pressure vessel, this damage mechanism is not there. Okay. Now, sulfuric acid, which affect generally carbon steel and other alloys. Again, nickel based alloys are highly resistant. I told many damage mechanism nickel will be resistant. For example, highlight this one. Sulfuric acid promotes general or localized corrosion, carbon steel and other acyl. Carbon steel, steel, HH may experience oxide corrosion. In order of increasing resistance, carbon steel is the least resistant. In order of increasing resistance, least resistant is the carbon steel, highly affected. Then stainless steel, alloy 220, high silicon, high nickel castane, alloy B2. Then last is important, alloy C276, that is a nickel based alloy, is a highly resistant. So which material is highly resistant? Open book question is alloy C276. Now, there are two types of acids. One is called diluted acid and another one is called concentrated. Which one will cause more corrosion? Diluted acid will cause more corrosion than concentrated. So highlight this one: acid concentration, temperature, alloy content, velocity, contamination, and the presence of oxidizers. Then D is important. Carbon steel corrosion rate increases significant, the flow velocity 2 to 3 foot-pounds and the concentration below 65%. So that the diluted acid concentration less than 65% will have more corrosion, and when its flow velocity more 2 to 3 will have more corrosion. Since this condition reduce the ability to maintain a protective ferrous sulfate. Then highlight the H. Stainless steel performance can be similar to carbon steel, especially in less than 92% sulfuric acid or at elevated temperature. The addition of molybdenum to 300 stainless can improve resistance than less than 92%. Just to highlight this, not important. Then please go to the next page. How the appearance. Knife line grooving is typical on top of horizontal piping where hydrogen bubbles form and travel along the pipe. Areas of fan-shaped, delta-shaped corrosion are common at the elbows. So delta-shaped means this, the fan-shaped, this shape, the fan blade regular. It is a fan blade shape. Then sulfuric acid attacks slag left from welding. If the slag is not cleaned, then it will sulfuric acid will attack. Then prevention, highlight this one. So corrosion is minimized through proper material selection and proper operations. Alloys such as alloy 20904 alloy will dilute, resist the dilute acid and form a protective iron sulfate films. That also highlighted. The inspection, corrosion can be monitored with the coupons and the ER probes. So again, electric resistance coupon and ER. Yeah. Electric resistance probes. If you go to the next page, this was asked in open book question. You can see sulfuric acid corrosion rate chart for carbon steel. If you take x-axis, they are given percentage of sulfuric acid, y-axis they are given temperature. For example, percentage of sulfur is 80%, temperature is say 225. What is the corrosion rate? 75% 225. It will be approximately 200 mils. It is very close to 200 mils. Here it is 50. Here it is 200. In between 50 to 200. Okay, so you can see here. See, if it is, for example, if you take any 75%, up to 75 degree Fahrenheit, less than 20 mils. If you reach more than 75, 20 mils, then this range is 20 to 50. Then 50 to 200. This is over 200. So that's all internal corrosion. Now we will go to the, we will start from brittle fracture. Please take the brittle fracture. Now we will go continuously. Yes, page number 49. Now, very important damage mechanism. Brittle fracture. What is brittle fracture? What is the definition of brittle fracture? Sudden rapid failure without a plastic deformation. Plastic means there will be no elongation. It will break straight. That is called a brittle fracture. Point number 1, page number 49. Okay. Next one. So brittle fracture is sudden rapid failure without. You remember tank we have studied in 653 that we exemption curves below half an inch it will not fail brittly, above 60 degree Fahrenheit it will not fail brittly, What is the membrane stress required? 7,000 psi to brittle fracture, all these things. Now, that is the definition of brittle fracture. Which material it will affect? Brittle fracture, carbon steel, low alloy steel, 400 series stainless steel. 400 series means ferritic and martensitic. 300 series will not fail brittle failure. Austenitic stainless steel will not fail brittle. That is the second thing. Now, what are the critical factors for brittle fracture? The most important critical factor is the temperature. Below certain temperature only, brittle fracture will happen. The temperature is depends on the material and the thickness actually. Okay. What is the temperature is called? Transition temperature. Very, very important. What is the temperature is called? Transition temperature. So transition temperature means above transition that material will be ductile, below transition it will become brittle. At which temperature material change from ductile to brittle, that is called a transition temperature. Okay. Temperature is the most important critical. Now the next one is the thickness. High thickness will have a brittle fracture problem or low thickness. High thickness. When the thickness increases, brittle fracture possibilities are high. You know, as per 653, when the thickness is less than half an inch, brittle fracture possibilities are very less. Second point. Third one is the grain size. Which one will have a brittle fracture possibility? Coarse grain or fine grain? Coarse grain, because fine grain will have a more toughness. More toughness means less brittle. Fourth one is a steel cleanliness. You remember 650 capped steel, rimmed steel, semi-killed, killed. So killed steels will have less problem compared to the capped or rimmed steel. Steel cleanliness is the fourth one. These are the four critical factors, but the most important critical factor is the temperature. Next one is how the appearance will be of the brittle fracture. For example, a brittle fracture, the material will break into two pieces like this. It will become straight because there will be no elongation. But sometimes you can see in the broken piece, there will be a small, this is called small piece shear lip. This is called a shear lip. A small piece will be there like this. It will be straight and a small shear lip. Another one is, so if you have a material with the grains like this, and if the crack follow a grain boundary, this is called intergranular. If it is follow the grain boundary, then it is called intergranular. Suppose if it is not following the grain boundary, it is going like this straight, then it is called transgranular. Now, by seeing this picture, tell me how the brittle fracture will be, intergranular or transgranular?
Transgranular.
It will be generally transgranular because it will go straight. Okay, transgranular. Third, another one more appearance is, if you take a brittle fractured surface, the brittle fracture start from some notches only, it will start. Suppose there is a notch, then you can see the fracture surface will have mark like this. These marks are called chevron marks. These are important. A brittle fracture can have a shear lip. Generally, it will be limited intergranular, mainly transgranular, or it can have chevron marks also. So if you want to mark it, then welcome. Note பண்ணா பண்ணி. Is it okay? Now, this is about the how the appearance will be. I told you critical factor appearance. Then how to prevent it? So only thing you have to select the material. Material selection is very important. Suppose if you know the tank or pressure vessel is going to operate in low temperature, we have to choose the material accordingly. So generally for cryogenic, we call it as a cryogenic, we will go for stainless steel. If you use a normal carbon steel, it can go up to minus 20 degrees centigrade. Okay, that is selection of material is very important. Second one is the hydro test. Generally, brittle fracture will happen during hydro test only. You remember tank also, once it withstands the hydro test, it will not fail during the service. So that's why particularly pressure vessels, I think 653 there is no rules, but 510 and 570 there is a rule. When you are doing hydro test in winter, you have to use a warm water. There should be water temperature should be minimum design metal temperature plus 30 degrees Fahrenheit. The purpose of using warm water is if you use a cold water, it may promote a brittle fracture. Then find plus 30 design plus 30 degrees Fahrenheit you have to add it. Water temperature. Okay, but a maximum 120 degrees Fahrenheit. It is all Fahrenheit. Centigrade 120 centigrade water will evaporate into steam. 100 MDMT plus 30 all Fahrenheit only. Okay. Then finally, which NDT will detect brittle? Another very important, NDT cannot detect whether a vessel or tank is going to be failed brittle. Only thing if you have a doubt, because brittle fracture start from a surface defect. So we have to check for the surface NDT whether any defects are there. There only it will start. If you find any cracks developing there, then it may fail. Immediately we have to take the corrective action. So sometimes if it become brittle, then what is how to you can reverse the brittle by using the heat treatment, tempering. Tempering will improve the toughness. Okay, so please take code book. Another important damage mechanism, brittle fracture. Brittle fracture is a sudden rapid fracture under stress where their material exhibit little or no evidence of ductility or plastic deformation. Although rare in refining operation, in-service brittle fracture of a pressure vessel or other pressure equipment have serious consequences. That is closed book question. Now, affected materials. Carbon steel and low alloy steels are prime concern, particularly older steels. 400 series also are susceptible if not embrittled. So it will not affect 300 series, but it will affect carbon steel, low alloy steel, and the 400 series. Critical factor, the material toughness, size and shape of stress concentration, the amount of residual or applied stress. Then C highlight, steel cleanliness, level of sulfur, phosphor, and other impurity, and grain size have a significant influence on toughness and resistant to brittle fracture. That is open book question. Then C, thicker material section have an inherently lower resistant to brittle fracture due to the nature of stress state within the thick. That is a open book question. And F, very important, in most cases, the material that exhibit ductile to brittle transition, brittle fracture occurs only at temperature below the Charpy impact transition temperature. The temperature at wet and below which the toughness of the material drops off sharply. Then appearance, highlight this one. Cracks will be typically straight, non-branching, and largely devoid of any associated plastic deformation, although fine shear lips may be found along the free edge. There will be a fine shear lips. And B, in fractured surface, the undamaged initial will exhibit visible chevron marking that point back to the crack origin point. That is open book question. Then microscopically, the fracture surface will compose largely of cleavage with limited intergranular fracking. So very limited intergranular, it will be transgranular. Prevention. For most new equipment, brittle fracture is prevented using materials in compliance with the UC 66 of ASME Section 8 boiler pressure vessel code. So the material selection is the best prevention method. That D is important. Where brittle fracture is deemed concern, some reduction in the likelihood of brittle fracture may be achieved following AP 579 ASME fitness for service. Then inspection, routine inspection is not normally used to detect or mitigate the brittle fracture, but awareness of such equipment can help prevent future damage. That is important. So generally, routine inspection will not find out the brittle fracture. Then B, successful vessel can be inspected for pre-existing crack-like fabrication flaws, as well as for cracking from the in-service. That is open book question. So this is how it will fail brittly. So how many questions we marked? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. So we completed brittle fracture. Then we'll go to the 3 more. Caustic stress corrosion cracking or caustic embrittlement. Okay. What is caustic? I told you what is caustic? Sodium hydroxide or potassium hydroxide. It is an alkaline chemical. You remember caustic corrosion we see in the month. It is alkaline chemical. It is a boiler related damage mechanism. I told you if the caustic is freely moving in the water wall tubes, because of the temperature more than 170 degrees Fahrenheit, it will cause a corrosion. The corrosion will be in the form of grooving. This all we see in the caustic corrosion. Okay. Now, first understand what is meant by stress corrosion cracking. Just 1 minute, let him come. Just a minute. Okay. Now, what is meant by stress corrosion cracking? Stress corrosion cracking or environmental cracking, both are same. Point number 1. Stress corrosion cracking, not only caustic. We have many environmental cracking, but for our 653 only 2 caustic and chloride we have. So we have caustic, amine, many environmental crackings are there. All environmental cracking is called as a stress corrosion cracking. Why they are called as a environmental cracking? The corrosion is caused by the environment inside a piping or tank or vessel. But if there is a stress will combine with the corrosion, it will cause stress corrosion cracking. Okay, so now where we will have a stress in a material where it is not post-well heat treated. See, very simple. Where the caustic corrosion will happen, we say it is happening in water wall tubes. How the water wall tube appearance will be grooving. If this grooving is near a weld, tube weld, if it is not post-well heat treated, there will be a stress. Then the stress and the corrosion combined, it will cause stress corrosion cracking. That is called stress corrosion cracking. So for all stress corrosion cracking, we need a stress. Where we will get a stress when it's not stress relieved, there will be a stress, residual stress. and the corrosion is caused by the chemical. Here it is caustic. Next damage mechanism, it is by the chloride. Okay. Another common thing is all stress corrosion cracks are surface cracks. They will start from the surface. They are not internal cracks. Now, surface cracks, which NDT we will do normally? MTPT. But please remember, PT is not preferred for stress corrosion cracks because of the corrosion. The corrosion product will fill the crack. So Panattone will not go. So PT should not be used as a only method. So preferred method is wet fluorescent MT. ACFM, alternate current field measurement. What is ACFM? It is same like MPA. The difference between ACFM and MPA is MPA you can do only in ferromagnetic materials. You cannot do MPA of stainless steel, austenitic stainless steel. Whereas ACFM we can do in all conductive material. Austenitic stainless steel, copper, aluminum. We cannot do MPA, but we can do ACFM. That's alternate current field measurement. We are measuring the current leakage. In MPA, we are measuring the flux leakage. So ACFM we can. Another one is eddy current. Eddy current also same advantage. We can use all conductive material. But then what is the difference between ACFM and eddy current? Eddy current we can do up to 12 mm thickness. ACFM is the only surface because of the AC current. AC current have a characteristic called skin effect. You hear this word? Skin effect means alternating current will flow only on the surface. Only skin. Okay. So wet fluorescent MT, ACFM and eddy currents are preferred methods. Generally, PT should not be used as a only method. But if it is happening inside the surface, if you want to check from the outside, we cannot do surface NDT. Then we have to go for a shear wave ultrasonic testing. That is angle beam or PAUT. What is PAUT? Phased array, we have to go for it. There is one more NDT that is called acoustic emission, AET. What is meant by acoustic emission testing? Is ultrasonic also sound? Then what is the difference between ultrasonic and acoustic emission? Ultrasonic, we are sending the sound to detect a existing crack. Whereas in acoustic emission, we will keep a probe permanently. If any crack develop, it will emit some sound. Any paper, if you are tearing a paper, if anything fallen, it will create a sound. So same way, when any cracks develop, there will be a sound will be coming. If we keep a permanent sensor or probe to pick the sound, we can monitor the growth. So that is called acoustic emission testing. In storage tank, acoustic emission testing is used during, suppose the tank, even it become brittle during service, it will not fail brittly. When it will fail, I told you, during hydro test. If you are doing any major repair or alteration, or if you are changing the service to more severe service, we will go for the hydrostatic test. So hydro test only the brittle fracture will happen. So how to monitor to brittle fracture, whether it is starting? So what they will do, which joint is more critical in the storage tank? Shell to bottom weld. So they will keep the acoustic probes all over the shell to bottom weld and start filling the water. Any cross developing, they will immediately stop the water filling. We have to go for a corrective action. Okay. Acoustic emission testing is used to monitor the process. Okay. This is about the caustic stress corrosion cracking. Now, next one, which material it will affect? Caustic corrosion will affect, I told, carbon steel, low alloy steel. In austenitic stainless steel, if passivity is damaged. But here it will affect carbon steel, low alloy steel, and austenitic stainless steel also, because it is a crack. The next one, how the appearance will be. Caustic corrosion, how the appearance will be? Grooving. Here it will be spider web. This cracks will be spider web. They will have a spider web pattern. Then how to prevent it? Very, very important. We have to relieve the stress. How will release the stress? PWST at 1150 degree Fahrenheit. We have to do the PWST. Another one is, if any vessel in caustic service, it should not be washed with the steam. The steam will give the heat, it will produce cracks. We have to wash with water, then we have to wash with the steam. These are the key points about the caustic stress corrosion cracking, very important damage mechanism. So please take. pH எல்லாம் கிடையாது. வாட்டரை வச்சு கிளீன் பண்ணிட்டு அப்புறம் ஸ்டீம் எடுப்பாங்க. Caustic SC is characterized by surface initiated cracks that occur in piping and equipment exposed to caustic at elevated temperature, primarily adjacent to non-PW steel weld. That line is important. Primarily adjacent to non-PW steel weld. Affected materials, carbon steel, low lateral and 300 series are susceptible. Duplex stainless are also susceptible. Nickel based alloys are more resistant. That is important. Nickel based alloys are more resistant. Still it can happen. Yeah, it is not affected. More resistant means it will not affect easily. Affected. Lower loss will be affected. We will see, no problem. 400 series also affected. Only nickel based alloys are more resistant. We will see question bank. Wait. Criticality, critical factors, caustic strength, metal temperature and stress level. Highlight the B. Increasing caustic concentration and increasing temperature increase the likelihood and rate of cracking. Then this is another important. I forgot. Cracking can occur low caustic level if concentration mechanism is present. In such cases, caustic concentration 50 to 100 ppm are sufficient to cause cracking. So even 50 to 100 ppm will cause cracking. Then E, thermal stress relief is effective in preventing caustic. CWST is effective in caustic SCs. The next page, appearance. Caustic SCs typically propagate parallel to the weld adjacent to base metal. It is only parallel to the weld, but in the zone of highest welding, but it also occur in the welded deposit. So generally it will propagate parallel to the weld. The pattern of cracking in the steel sometimes described as a spider web of small cracks. So you'll have a spider web. That is important closed book question. Then prevention, another very important closed book question. Cracking can be effectively prevented by means of stress relieving a PWST at 1150 degree Fahrenheit, minimum holding of 1 hour. That is very important. Prevention on the you have to do PWST at 1150 for 1 hour. Then B, 300 series offer very little advantage. C, nickel based alloys are more resistant to cracking and may be required at high temperature and high caustic. So you have to go for a nickel based alloy. Then D also important. Steam out of the non-PWG carbon steel and the equipment should be avoided. Where necessary, equipment should be water washed before steaming out, and only low pressure steam should be used for short periods. That is open book question. Then inspection. Wet fluorescent MT, WFMT, ACFM, and ECT can be effective technique to detect the surface breaking crack. How to prepare surface preparation into cracks? The preparation necessary to ensure cracking not masked by blending depends on the techniques. Angle beam, shear wave PAT can be effective to detect and size cracks. And this ultrasonic can be used to periodically monitor cracks. And PT may not be effective for finding fight cracks because the cracks are oxide filled. That is open book question. RT may not be effective in detection of tight cracks. AET can be used for locating cracks and monitoring crack growth. So we can monitor crack growth, we can use acoustic emission test. And you can see next page, there is a figure chart. If you see this one, you can see x-axis, it is given concentration of sodium hydroxide, and y-axis temperature in Fahrenheit. And there are 3 areas, area A, area B, and area C. So how the exam question will be asked if they ask for caustic concentration 20% and the temperature 200 degree Fahrenheit, which of the following material should be used to prevent caustic SCCs? So which material? Carbon steel with the PWST, stress relief. So you can see 20, 200 will come area B, carbon steel with the PWST. So you have to match this 20 with the 200 here. I told you 200 degree Fahrenheit. Suppose it is 240, then it will area C, nickel based alloys, you have to go for it. Then if it is only 140, then it will be area A, carbon steel without the PWST. Okay, so how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the last one, oh, then we have two more. We have two more. Chloride stress corrosion cracking. இதுலங்க concentration, see what is this?
180 kilo concentration.
இதா
180
இதா
160 இந்த ஏரியால
இந்த ஏரியாவா இங்கயா
170
see, if your percentage and temperature follow below this line without PWST, between these two line, anything follow this line, carbon steel with the PWST, anything follow above this line, nickel. So what is your question? Ask
170 னா நம்ம
170 ah
170 தான் house
10 க்கு 170 ah. So 10 is here, 170 will come here, so no PWC required. Because 171, then PWC we have to go for. Yes. Next, we will go to the chloride stress corrosion cracking. So what is meant by chloride stress corrosion cracking? This is a special damage mechanism. What is the specialty in this damage mechanism is it will affect only austenitic stainless steel. Chloride stress corrosion cracking will affect only austenitic stainless steel. It will not affect carbon steel or lower layer steel. Okay. Now, I told you this three combination generally not advisable. A austenitic stainless steel, chlorine, temperature more than 140. This three when combined, it will promote a cracking that is called chloride stress corrosion cracking. So the second important point is chloride stress corrosion cracking will happen only when the temperature is more than 140. So we need a 300 series stainless steel, temperature more than 140 and chlorine. Okay, that's why water, when you are using stainless steel hydro test, water chlorine content should be less than 50 ppm. When you are doing PT, stainless steel, it should be less than 1% weight. Okay, that's why generally we will avoid always chlorine with the stainless steel. Temperature also important. Okay, now chloride stress corrosion cracking is the cracking caused by environmental cracking caused by the chlorine content in austenitic stainless steel above 140. So generally, where will be stress on the non-PWC device? But here problem is we see just caustic stress corrosion cracking. What is the corrective action? We will do PWC of the 115. But the stainless steel, generally, we are not doing PWC. Why we are not doing PWC stainless steel? Have you seen they're doing stainless steel PWC? No. Why we are not doing PWC of stainless steel? Because PWC stainless steel well also will have residual stress. But the problem if you do PWC, how we will do PWC? Slowly heating, holding, slowly cooling. When stainless steel is more than 400 degrees centigrade for longer period, chromium and carbide will come out, form a chromium carbide in the grain boundaries. Because of the chromium carbide formation, there will be reduction in the chromium level. Then the stainless steel will start corroding because chromium oxide only protect. That's why we are not doing stainless steel. PWS has the stainless steel. So now here, then how to control this one chloride stress corrosion cracking? We have to reduce the chlorine level. We have to go for a low chlorine. PWST, is it possible to do stainless steel? Yes, it is possible, provided you have to heat it fast and cool it fast. We will not heat it slowly. Okay. Now, what are the critical factors? Which material it will affect? I told you. So, what is the definition of chloride stress corrosion cracking? Environmental cracking caused by the chlorine and the stainless. Which metal affected metal? I told you 300 series it will affect. Nickel based alloys are resistant but not immune. Nickel based alloys also it will affect. Okay, whereas carbon steel, lower layer steel, it will not affect. Okay, next. What are the critical factors? Temperature is the critical factor. When the more than 140 only, it will happen. Then chlorine content, more chlorine, more possibility of the cracking. Now, if you take stainless Stainless steel, what material will have stainless steel? What element? Chromium and nickel. Nickel plays an important role. Okay, if the nickel content is 8 to 12%, they are highly susceptible to this problem. When the nickel content is above 35%, they are highly resistant. When the nickel content is above 45%, they are nearly immune. Nearly immune means almost it will not come, but still there is a possibility. Only carbon steel, low alloy steel, it will not come. Okay, then how to prevent it? I told you PWST is the option, but generally we are not doing PWST because PWST will result in another problem. We try to avoid one problem, but it can create another problem. So go for a low hydrogen, low chlorine 6. And NDT, again, because it is a stainless steel, we cannot go for MT. Eddy current techniques are preferred techniques. PT also we can. Okay, so these are the. எது எதுல அதுல. Okay, so please take. Surface initiated cracking of 300 series and some nickel base alloy under the combined action of tensile stress, temperature and aqueous chloride environment. It is also referred as chloride cracking. That is closed book question. Affected material, all 300 series are highly susceptible. Duplex stainless are more resistant but still susceptible. Nickel based alloys are highly resistant but not immune. That is important. Open book question. Critical factors: chloride content, temperature, pH, tensile strength, presence of oxygen and alloy composition of critical factors. Then C, increased levels of chloride increase the likelihood of cracking. Open book question. And D, increasing temperature increase the potential for cracking as long as other lacquer elements. Then one second line is very, very important. Cracking usually occur at metal temperature above 140, and the experience has shown this be a useful temperature for the fixed refining equipment. Then this I forget. The potential for cracking increases at lower pH. However, SCC usually does not occur below 2. So only pH below 2 it will not occur. Above 2 to 7 only it will occur. Then these three are important. Nickel content of the alloy has the major effect on resistance. The greatest susceptibility occur in stainless steel with the nickel content 8 to 12%. And the next, alloy with the nickel content above 35% are highly resistant, and alloy above 45% are nearly immune. That also important. Then appearance, surface breaking cracks can occur from the process side, external and insulation. Then see characteristic of cracks, many branches and visually detect with spider web and cross cracking. That is open book question. Spider web or cross crack. Tracking of tensile 300 series may be intergranular. Then prevention, highlight the A. Material of construction resistant to chloride SCC should be used. Carbon steel, low alloy steel and 400 series are not susceptible to chloride suppression cracking. Then highlight the B. When hydrostatic low chloride content water should be used, followed quickly by through dry out. Then inspection, VT can be used, PT can be used to chloride. However, extremely fine cracks may difficult detect PT. Special surface preparation methods, including polishing, high pressure water blast may be required. ECT, eddy current inspection methods can be used on condenser tube as well as piping and pressure vessels. That is closed book question. Angle beam and opposite side can be used to detect as RT is not often sensitive. Not sensitive. That's all. RT generally for stress corrosion crack, it is not preferred because the cracks are tight, may not be detectable by radiograph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes, please. Which one? PWC பண்ணிட்டு போஸ்ட் ஹீட்டிங் பண்ண மாட்டாங்க. போஸ்ட் ஹீட்டிங் பண்ணா PWC. அது இல்ல. So finally, fatigue. Fatigue, mechanical fatigue. Due to another important damage mechanism. Now, what is meant by fatigue? What is fatigue? It is called generally fatigue means cyclic loading. What is meant by cyclic loading means a high fluctuation in pressure or temperature. That is called fire. So it is actually nothing to do with the tank actually. It is related to pressure vessels and the piping. Now, if you understand this, suppose a pressure vessel operating pressure is say 100 psi. It is very difficult to operate exactly at 100 psi. There will be a small fluctuation which is allowed, which is set by the owner. Owner will set the fluctuation how much. For example, owner setting 95 to 105, it can fluctuate. That fluctuation range is called as IOW, integrity operating window. But if it is fluctuating excessively, then it will fail below yield strength also. It will fail so quickly. That is called fatigue failure. Fatigue failure, cyclic loading means pressure going up and down or temperature is going up and down. If it is only due to temperature, that is called thermal fatigue. If it is pressure or temperature under pressure or vibration, it is called mechanical fatigue. Okay, mechanical fatigue means due to fluctuation in pressure, due to temperature under pressure, or due to vibration. These are called mechanical fatigue. Okay, that's the first one. Second one, which material it will affect? It will affect all materials. It is not a material dependent. Second one. Then what are the critical factors? The most important critical factor is surface notches. Fatigue failures also surface cracks, but stress corrosion cracks, we needed no assistance. But here we need a surface notch to start the crack. What is meant by surface notch? A weld undercut, weld ripple, grinding mark, tool mark, arc strike, okay, punch, hard stamping, drilled hole. These are considered as a surface notches. Yeah, weld, if it is a, there is a weld ripples, I told. That's why if any vessel or piping in fatigue service, you have to flush grind everything. You have to make a smooth grind. Oh, another problem is all materials have two types of strength. One is called yield strength, another one is called tensile strength. What is mean by yield strength? When you give the load to the material, the load is called as a stress. There is a change in dimension. That change in dimension is called strain. When there is a stress, there will be a strain. When you remove the stress, if there is no strain, then it is called elastic. If you are giving load, pulling, the dimension change. Leave it back to the original dimension. That is called elastic. All materials will behave up to certain load like that only. But when certain load is exceeded, even if you remove the load, the deformation will be permanent. That is called a plastic. So generally, engineering material means like steel will not fail below yield stress. Okay, above the elastic plastic only it will fail. But if you are in cyclic loading, it will fail below yield strength also. There is one word called endurance limit. What is endurance limit means? If you reduce the load below certain load, the material will not fail. That load is called the endurance limit. Endurance limit below at which load the material will not fail. That is called the endurance limit. Now another one is grain size. You remember fine grain will have a toughness. Same way fine grain will have a fatigue resistance also. That is about this one. Now, what is the endurance limit for carbon and low alloy steel is generally 40 to 50% of the tensile strength. But austenitic stainless steel and aluminum does not have the endurance limit. That means even if you go very low load, if it is in cyclic loading, up to after 1 million cycles, 10 to the power 6, it will fail, it will crack. Then how the appearance will be? Again, we have some 3 different nicknames. Suppose if start from a surface notch, I told you it will start from the surface notch. If it starts from one single surface notch, the fractured surface will have an appearance like this. This is called clamshell. Clamshell, seashore, sea, we will getting that. But if you have multiple notches, the clamshell will overlap. These are called beach marks. Okay. Suppose you have in different directions the overlap like this, then these are called ratchet marks. So write this. These are the different characteristics.
Why these marks are forming, sir? What did you mention, sir? Why
These
these
are
marks?
called clamshell because they start from a surface notch. These are called clamshell marks. If it is multiple notches, it is one notch, it is called clamshell.
Why is
Clamshell
that? Is formed because of the
fluctuation. Fluctuation, because every time it is fluctuating and breaking very slowly. That's why these marks are forming. But if you have multiple fluctuation, we call it as a beach mark. Beach mark means how the seashore the line will be formed. If it is in different direction, this is called ratchet marks.
So when there are marks in the tab,
yes, fractured surface. If we see this mark, this type of mark, then we can say it is due to fatigue failure. Fractured surface, only we can see the marks.
Okay.
Now come to finally how to prevent it. So I told you design, or we can go for heat treatment also. Improve the grain size. Then which NDT will detect? Because here there is no corrosion, we can do PT also. We can do PT, MT, but if it is happening inside, we can use a UT also. Okay, so please take. Fatigue cracking is a mechanical form of degradation that occurs when the component is exposed to cyclic stresses for an extended period. Dynamic loading due to vibration, water hammer, unstable fluid flow, often resulting from sudden, unexpected through-wall cracking. That is important. This stress can rise from either mechanical or thermal cycling and are typically well below the yield strength. That is close to question. Then material all affect, so that is not important. Critical factor, geometry, stress level, number of cycles, and the material's properties. Strength, hardness are the predominant factors. Design factors, fatigue cracks usually initiate on the surface at notches or stress risers under cyclic loading. For this reason, design of a component is the most important factor. So where it will come, mechanical notches, tool mark, grinding mark, thread, all these things. These are important. Now, metallurgical issues. Some materials such as titanium, carbon steel, and low alloy steel have an endurance limit. In such cases, the number of cycles to fatigue fracture increases with decreasing until amplitude limit is reached below the fatigue, which fatigue cracking regardless. So below endurance limit, it will not occur. That is close book question. 300 series SS, 400 aluminum, and most other non-ferrous have a fatigue characteristic does not exhibit endurance limit. So maximum cyclic stresses selected determined 10 to the power 6 to 10 to the power 7. Now 6, Heat treatment can have an effect on fatigue resistance of a metal. In general, fine-grained microstructure tend to perform better than the coarse-grained. Heat treatment such as quenching and tempering can improve the fatigue resistance. Now, where the vibration will be there, near the pump or compressor, small bore line, which is not supported, will vibrate more. That is called vibration influence induced fatigue. Socket wells and small bore piping associated with near pumps, compressor, and other rotating reciprocating equipment that are not properly gusseted or supported. Then appearance, these are important. Damage is usually in the form of crack emanation from a point high stress concentration. Okay. Then B, the signature mark of fatigue failure is a clamshell type fingerprint that has concentric rings called beach marks. That is closed book question. C, cracks nucleating from a surface or stress concentration or defect will typically result in a single clamshell fingerprint. That is closed book question. Then cracks resulting from a cyclic overstress of component without one significant isolated stress constant will typically result in a fatigue failure with multiple points. These are called ratchet markings. Then prevention. The best defense against fatigue cracking is good design that helps to minimize stress concentration of components that are in cyclic service. Then highlight the 7, minimize welded defects, as this can accelerate fatigue cracking, minimize grinding marks, nicks, gouges, use low stress stamps and marking tools. Then inspection, PT can be used to detect cracks open to surface, MT can be used to detect cracks open to surface or near surface. Angle beam can be used to detect fatigue cracks or known or suspected areas. Here we UT or PUT. That's all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. Now, so we have completed the damage mechanism. We will go to the question review directly.
So 5 minutes break, sir.
Break will be 11 o'clock. Okay, we have 100 questions actually. Who will start? Each 20. Yes.
A sudden rapid fracture under stress without plastic deformation is called.
So sudden rapid fracture under stress without plastic, brittle fracture.
Without the following materials are not affected.
Which one not will have the brittle fracture? Astatic stainless steel. It will affect carbon steel, low alloy steel, and 400. Next.
Which of the following is caused by cyclic stress often resulting from sudden rapid fracture?
Cyclic stress means fatigue. Next.
Which of the following will have most severe atmospheric corrosion?
Which will have marine environments and moist polluted industrial environments. Next.
The corrosion rate of marine environment.
Marine it will 20 mils per year. Polluted industrial 5 to 10. Wet rural 1 to 3. Dry rural less than 1. Next.
Which of the following material will CUI affect?
It will affect all. Carbon steel, low alloy steel. Just listen it. We can review later also. We can work it out. There is no problem. One time I will review. No problem.
CUI will appear in austenitic stainless steel.
Chloride suspension cracking, because stainless steel the temperature is more than 140 and the insulation will have the chlorine. Next.
Which of the following material are not affected with cast?
I told you nickel base alloy, carbon steel, low alloy steel, for it is a 300 series. Because 300 is only passivity damaged. Okay, next.
Caustic corrosion is most often associated with
Boiler and steam generating. Caustic corrosion is generally boiler steam generating related.
Which of the following materials are highly susceptible?
300 series only it will come. It will not come in carbon and low loss. I told chloride stress corrosion, the specialty is it will affect only astatic stainless steel. Next,
Chlorine stress corrosion cracking usually occurs
140, very, very important temperature.
caustic CC occur in piping and equipment exposed to caustic chemically
Adjacent to non-PW steel. We need a stress near non-PW steel.
So the following material is more resistant to caustic.
I told caustic opposite is nickel.
Soil water corrosion is corrosion of steel due to acid soil water and an insidious
4.5 to 7.
So the following will increase the susceptibility of the defect.
Of steel, which are the all of the thickened material, operating temperature below, steel cleanness, all will affect the brittle fracture.
Fracture normally occurs at
Below transition temperature.
fracture is best prevented.
How will prevent it? No. Best one, the conducting using a suitable material for low temperature. That is the best prevention. Best means only one. Next,
Which of the following will have better taking resistance?
coarse grain will not have steel casting, fine grain material. Fine grain will have a fatigue resistance. Next,
Mechanical fatigue cracks are characteristic, right?
no chevron. That is brittle. Beach marks. Beach marks. Beach mark, upper clamshell, ratchet marks. Next,
Which of the following temperature will have high atmospheric?
another very important, only up to 250, the atmospheric corrosion will be increasing. Above 250, it will not corrode. Another 5 questions, each 25. Padinga, Nanji padinga, 25.
Okay. The prevention for atmospheric corrosion is
Atmospheric corrosion, what we can do? Surface preparation and proper coating application.
for insulated carbon steel components. Corrosion becomes more severe at metal temperature between
Carbon steel, it is 10 to 350. Astatic stainless steel, 140 to 350. Duplex, 280 to 350. 212, it is not there. Okay. Next.
the following equipment are not susceptible to CO.
Piping equipment damage, yes, possible. Renovation of insulation, that also possible. Localized damage paint coatings, that is also possible. Equipment located upstream of cooling towers. Before cooling tower, it will not affect. Only after cooling towers only it will affect. Next.
The CO mitigation is best achieved by
Maintaining a insulation and sealing vapor barriers. You have to maintain a barrier.
caustic corrosion is characterized by
Groove. Caustic corrosion will be a groove. Yes, sir. Next to 25.
caustic corrosion is best prevented.
Proper design. I told you we should not allow water. See, we should not allow caustic separately. We should always mix it with water. Next.
Caustic corrosion is formed of high strength caustic solution.
So it is actually 170. Now it is revised. It is based on the old revision. We will change it. Question number 27, we will change it. It is now 170. Next.
Chloride,
But the pH values above 2. Below 2, it will not occur. Next.
greatest susceptibility of chloride is at nickel content.
So greatest susceptibility 8 to 12. Above 35 highly resistant. Above 45 nearly immune. Next.
45% is nickel content.
Nearly immune. Next.
Plastic concentration, plastic
SCC occurs
concentrating mechanism.
50 to 100 ppm. There is only one damage mechanism. There is a ppm. This one only there is a ppm. Caustic 50 to 100. Next.
To prevent a caustic PWC should
Only one PWC temperature given this, that is caustic 1150. Next.
To prevent a caustic before steam out, it should be
Water wash. We should not clean with directly steam. We have to wash with water first.
the following MDB detect the possibility of
NDT cannot detect the possibility of the brittle fracture.
Then the following the best way to reduce static.
Good design to minimize stress concentration. So there should be no stress concentration like surface notches.
Then the following will reduce the possibility of
So which is used chrome sulfate, operating temperature no, controlling. So closed self-foam glass. We should use a special insulation which will not absorb moisture. Next.
then the following NDT method will detect the
Neutron backscatter and infrared thermography. Here there is only neutron. This is to measure the thickness through insulation.
then the following material is resistant to caustic.
Caustic alloy 400. Alloy 400 is a nickel based alloy.
Then the following NDT method are preferred to detect the fluoride.
PT at the eddy current testing.
Then the following surface separation method for detection of this fine fluoride stress corrosion crack.
High pressure water blast. We have to use for water blast or polish.
Detection is best to perform with WFMT.
EC, RTR, ACFF. These are the NDT method for caustic suppression cracking.
Then the following surface preparation methods for casting detection.
So surface preparation. Now they removed actually this one. Grid blasting and high pressure water blasting. Again, we have to change it. Now they change it to, it depends on the, we have to, they have not given this requirement. Now next.
300 series material classification specific L and H stands for
Low carbon and high carbon.
Nickel is alloy contains nickel greater than
30%. Next. AUBT stands for automated ultrasonic backscatter testing.
fact that are typically straight, non-branching, and
Devoid of any associated plastic driven likelihood as with type of failure, brittle fracture.
of the following are found along the free edge of the fracture are localized in the ground.
Shear lips. Shear lips. Next.
For new equipment, brittle fracture is best prevented by using.
So materials specially designed for the low temperature operation. We have to change the material.
The vessels should be inspected for free existing flaws defect to detect the possibility of
Brittle fracture, because you cannot detect by NDT, you have to check any flaws are there.
Vessels for mechanical fatigue and arise from either mechanical loading or thermal cycling and typically given.
Well below yield strength. Yes, please yourself. Another 25.
Fatigue cracks will only initiate on the surface and
At mechanical notches, grinding, all of them. Next.
fatigue cracks can be detected by
Petty cracks, generally we can PT, all of them. We can use, because there is no corrosion. We can use MT, shear wave UT, anything we can use.
most important factor in determining component resistance to mechanical fatigue.
That is the design.
Critical factors related to mechanical fatigue and fatigue resistance include
Geometry of component, stress and number of material properties, all of them.
atmospheric corrosion.
Can cause either uniform, that is correct. Yes. Either it can uniform or localized. Next.
Which of the following material is least affected by atmospheric corrosion?
So it will affect stainless steel.
Form of corrosion that occurs from moisture associated with atmospheric conditions, marine environment, and moist polluted environment and airborne contaminants and atmosphere and dry environment are very.
That is the definition of atmospheric corrosion. Least affected by, because stainless steel will not be affected by the least, it will not be. No. Okay, next.
Atmospheric corrosion rate vary greatly due to variety of factors. Corrosion rates increase with the temperature up to about 2 degrees Fahrenheit at temperature above 2 degrees Fahrenheit. The equipment surface are
Usually too dry to occur except CUI. Next.
With CUI, corrosion rate gas, which is making metal to find where the water is.
So it will increase with the increasing the metal temperature. Next.
Prevention of CUI best achieved by
Careful plan no. Using quality coatings. We have to use a coatings.
insulating materials often hold moisture that create corrosion. The ability of insulation to draw and hold moisture is known as
Wicking. That is called as a wicking.
rotation of equipment is a concern for CUI area. High moisture that require close surveillance of CUI.
So areas of high moisture in various downwind of cooling towers, yes. Areas with the DD system, areas with the acid vapors, all of them. Next.
Poor design and all installations that allow water to become trapped with increase.
Will increase poor insulation that allow water will increase the CUI. Next.
Flame spray aluminum coating have been used on carbon steel, but coating pores
By galvanic corrosion. That's why that is the purpose of aluminum coating. Which one? MIC. Lack of oxygen, light or dark, all of them. MIC pressure vessels, no. Storage tank, bottom. Yes, next.
Which of the following is a characteristic of MIC tank?
Cup-shaped pit within a pit.
Following is an effective method of preventing MIC.
Materials low velocity wrapping and cathodic protecting the underground structures. Next.
Gas is usually found in aqueous environment or service where water is sometimes or always present, especially where stag or low flow condition now.
That is the definition of MIC. Next.
Proper application of gas will control but not eliminate microbes that cause MIC.
Biocides. So if you add biocides, it will control but not eliminate. We have to need the continuous treatment. Okay, next.
All the smelling water may be sign of falling or
MIC. Bad smell will result in MIC. Okay, next.
a form of corrosion caused by living or other bacteria, algae or fungi that is often associated with the presence of tumor cells, any other known as
MIC. Next.
inspection and monitoring for MIC is done by
In cooling water, effectiveness treatment is monitored by biocide, microbe counts correct. Increase in loss of duty correct. All of the above are correct. Next.
which of the following material will not be affected by soil corrosion?
300 series. It will not affected by the soil corrosion. Yes.
Soil corrosivity is best.
How we are measuring soil resistivity testing. Next. Next.
The most effective products for soil corrosivity.
Most effective on the special back, no special corrosion resistant coating and cathodic protection.
Most common method used for one day undergoes oil use.
Near the potential structure potential we are voltage only we are measuring.
Soil corrosion appears as thinning with localized losses.
Due to pitting. Soil corrosion, it can be localized thinning or it can be pitting. Next.
Soil to air interface areas are usually more susceptible to corrosion
because of the moisture and oxygen. A and C. Next.
Soil corrosion affects
Carbon steel, cast iron and ductile iron. Next.
which are the following mitigating factors below operating soil growth.
Operating temperature, moisture and soil resistivity, all of the above.
Regarding soil corrosion, soil resistivity, people use to estimate soil corrosion. Soil corrosion resistivity is related to
Soil moisture content, amount of dissolved electrolytes, both the A and B. Next.
soil with high moisture content, salt concentration, high acidity.
Usually most corrosive. Let us complete only small little more. Yes.
Localized corrosion due to concentration of caustic or alkaline salt that usually occurs under evaporative conditions.
So caustic is called as a caustic corrosion.
Critical factors for chloride stress corrosion cracking include all of the following.
Chloride content, alloy comes except CO2. CO2, there is no relation between chloride and this one. Okay, next.
Store water corrosion in gas containing environment may be accompanied by carbonate disease.
So store water in H2S
H2S.
containing environments. Next.
300 series uses can be used for store water gas or chloride disease.
Below 140.
So the following entity method is to detect store water corrosion.
Ultrasonic, both A and B. Okay, next.
So the following materials is highly resistant to sulfuric acid.
Alloy C276.
Carbon steel corrosion rate increase significantly if acid is
Below 65, because diluted will have more corrosion.
sulfuric acid attack generally on the
Weld slag.
acid concentration, temperature, alloy content, and gas and
Stress on. No, it is not a stress corrosion cracking. Okay, let me try velocity. I have a doubt in this. Okay, next.
area of vulnerability in sulfuric acid alkylation. Units include reactor effluent lines, deep boiler, desorbitanizer, overhead system of the gas.
Caustic, I think. Okay.
With the sulfuric acid corrosion makes points, gas, gas, to relate to these and high corrosion. The gas becomes dilute.
Okay, with the water. Okay, let me check water, I think. Okay, let me check.
With sulfuric acid corrosion, the presence of oxygen, gas, gas.
Increase the corrosion rate.
Sulfuric acid corrosion, alloys such as alloy contain acid corrosion forms of
Iron sulfate.
sulfuric acid corrosion causes significantly the flow velocity exceeds about
2 to 3, I think.
the following entity method is used to detect sulfuric acid.
All of the above. UTR probes, corrosion monitoring coupons.
The following materials are suitable to the shore water corrosion.
Shore water corrosion, BN. Which of the following is successful? A. Carbon steel.
So the following entity detect the cost of the
I think it is a repeat. Entity cannot detect.
the stress below fatty crack will not occur.
Endurance limit. There may be 1 or 2 mistakes. Out of 1 or 2, okay, 4 mistakes. Okay, where are the mistakes? Let us check. Only last, the sulfuric acid, there may be mistakes. Here there is a mistake. Which of the following materials are not affected by caustic corrosion? Okay, check caustic corrosion.
400.
Was not affected by
400. Then the lower 400 carbon.
what are the affected materials?
300 series is generally
Material carbon steel, low alloy steel, and 300 series SSR first.
400.
So 400 series is not in the list. Okay, that is correct.
So 400 series are in the list, sir.
Not in the list. So 400 series not affected. Okay.
Primary carbon steel, low alloy steel, and 400.
And 300. Yeah. 400 series is not affected. Okay, right. Shore water corrosion. No, this is wrong. 4.527. Submitted is correct. We have to correct. 14, we have to change. This 4.527 only. So we have to change this. 14, there is a mistake. So 14, answer is C. We will change it. It is 4.527 only. I know this. Yeah. This is wrongly marked. For insulated, corrosion become more say metal temperature between. This one leave it. 22 we have to delete. No, 22 we have to delete. This is released. No, 22, because before there was a rule, more severe at a 220 to 12 to 350. Now they removed from the code. So 22, we will delete it. Okay. One more. Pore water containing environments may accommodated by CO2. That may be correct. Yeah, CO2, that may be correct because I have a doubt. Right.